Hello everyone, this is Steve. I'm going to welcome you to my YouTube channel for another video of reverse engineering. It's actually my second attempt. So in this one, I just wanted to kind of explain a few different things that's cool that's going on right now. The one thing I mentioned is this guy, he's fixing my Commodore 64 board. The good news is he was able to fix one, and he's going to give me a replacement of another board that he has working, and he's also going to create me a power adapter. So shout out to this guy. I'm going to put his channel here. So this is his channel right here. His name is pHYaFixedX. I don't know, something to do with technical stuff. But he fixes computers, and I threw a video on here not too long ago of him right here. Right here. This video's got 64 views already. It's him, this me talking about the motherboard and, you know, diagnosing it. So he's the one that's fixing my computer. So shout out to you, Mitch. And I think you really need to get more videos out. I think you've got some really cool hardware stuff that people would really like to see. So if you get the time when he's not fixing computers, I think he should upload some videos. So I'm sure he'll respond to this. So anyways, going back here. So the other cool thing that's going on is I've got this is basically a magazine that I've contacted over the internet here. That's a pretty popular magazine, Commodore Free or whatever. And they're going to be giving me an interview, so I'm going to be responding to these questions. And if all goes well, they might be able to promote my channel and bring it out there more to bring Commodore 64 into more in the limelight, especially the videos of the Commodore 64, which I haven't seen super popular on YouTube, but that'd be kind of cool thing to do. And we'll get right into the actual game. So I've got it running here. You can see, made a lot of changes here, and actually need to pause for a second. Also, I forgot to mention one more thing before we go into reverse engineer. If you can excuse me for a minute. So this book, Mapping the Commodore 64, a while back, I created an Excel document for it. I went back and I reviewed it recently, and I realized it's incomplete. So I'm actually going back, and I spent a lot of time last night, almost the last 8 hours or whatever, just typing in a lot of these, you know, lines and basically stuff for the listings and stuff like that back into the Excel document. So it's going to take me a little bit more time. I feel like I kind of went too quickly with it, and I really want to do it right because I want to, you know, get that back out there for you guys. So let's get back into the reverse engineering here. So I had to restart that because earlier I actually modified the screen for another video I was doing, and I had to remake it. So anyways, I wanted to show you these are the newer changes I've made, and so you can kind of see the screen. Well, actually, I need to position the sprite again. I forgot about that. So basically I just need to enhance the sprites. What I need to do here. Maybe if I rerun it again, maybe it'll work. Let's try it again. Okay, so I had to go back and rerun it here. I had to position the sprite properly on size on the screen, so I'm just going to run it and show it to you. So you can already see what I've done is I've added a multicolor sprite to this. I've changed some of the backgrounds of these characters. I changed the wall around here. I'm just redefining some characters. You might also notice the gold bar at the bottom of the screen there. Apparently I bump into it if I get right there. Also, if you touch the treasure chest here, it's supposed to pick a random direction and do something. You've been teleported. So it moved your character around on the screen to a different position. And last time I did this, it crashed the game. So let me see if I crashed it. Actually, I got lucky it didn't crash it this time. Because what it does is it picks an area in memory and it moves you in that area of memory. Okay, so everything else is the same. The monsters also, you may have noticed that earlier, they cannot kill me. All they can do is find my position and just stay there. Actually, I just erased my sprite. I noticed that. I'm going to go to this. It's also got the random position, so if you hit it again, it'll probably do something different. Oh, actually, it's teleported me again. It seems to be stuck on the teleportation now for some reason. Let's go try it one more time. It's supposed to pick random directions and do different things. You lost points. So there, you hit poison, you lost points. So this is kind of some of the things I added into the code. And really wanted to do in this video since we took a lot of the code apart already. I'll show you the newer changes I made with those teleportation, and I wanted to show you the machine language. So let me pause here. Also, I was going to mention, I took apart a lot more of the sections of code in here. You might saw this already showing on the machine language. And I went through and added. I had made another video earlier where I was going through line by line, but it took too long, so I'm not going to do that. Although this first machine language routine, this is the one that redefines the character set. but we'll get into the more the meat of the program now. So wanted to show you those changes I did. Here's where I did that amulet and teleportation and losing points and the poison and all that. Basically, I just set line 10, 5, 10. So as soon as you as soon as you run into the treasure chest, it sets a value for TR, treasure, TR, whatever I want to call that, and it picks a random location between. Actually, I might need to change this. See, 1, 2, 3, 4. Yeah, that's right. It picks a random location between 1 to 4 right here, and this +1 starts at a 4 instead of 0, and it goes to 522 or 523, 524, or 526, depending on which number. So we printed TR here. We might be able to see what it printed. Oh, actually, I just realized we need to set that to a non-integer. I could just do something like int TR to set it to just a number. I realized it was actually pulling decimal. That might be why it's not working properly. But anyways, it picks a random location, and if it picks 1, it goes to 522. Down here says you found an amulet. If it picks 2, it goes to 523. You've been teleported. And in 524, it goes down here and says poison. And the last one is 526, which is you found a magic wand. So that's kind of what that's doing. And I'll go back and I'll try to fix that later. Now I wanted to show you the machine code here. So this is on line 840. That's where it initializes it, at least. Right here's where it initializes it in the memory location 680. And you can see it starts at 6. This is at 681 here. So this is where it's basically redefining the character set. This 53248 is reading in the ROM area and moving it to RAM. I'll try to do another video later on character set because that's going to take too much time to show you in this one. And down here is the meat of the program. So I'm going to go into this line here in the code so I can show you where that's in here. I put 900, is it? That's where it reads it in. It reads it into 828 to 914. And in the code down in here is where it actually calls it inside of the main routine. So it's inside of line 280 here, where you see sys828 coming MX coming MY. So let's see if I do it right here if it'll work. Like that, it draws the map on the screen. And I found out some interesting things, and I'll go over this. So this first line here anyways is B798. And this is just reading from the data statements if you're just guys are curious down here. It's reading from these data statements down here, starting right here. And these are just, I use the monitor over here to kind of, figure out where it is, and actually almost defaulted there. But it's basically just pulled the code out of there so I didn't have to do it by hand or anything to see what the assembly's doing. So anyways, this first line here reads a parameter. So if we go back to line, was it 280? 280, which is the main routine calling for the joystick going backward and forward, moving your character around. It draws the map each time you're moving around. So the first line here is getting a parameter. This means to grab a parameter in memory. And I looked up this memory location in the map in the Commodore 64 book, which I showed you earlier here. It basically grabs the parameter at that memory location. Let's see if I can grab it here real quick. It's right here. So if I'll show you. See, 47003 there. It says, camera doesn't want to work now. Well, anyways, it grabs the memory location. I have no idea why this camera, there goes. Inputs a parameter whose value is between 0 and 255. Routine reads numeric XC program text, converts it to an integer, checks that it's in the range 0 to 255, stores it in the X register. This routine can be used for reading parameters from the USR statement or new commands. And that's exactly what we're doing here, is we're reading it as a parameter statement so that we can set these values. These are the parameters, by the way, this MX and MY. Those are the parameters. It gets the first parameter. We already know it reads it into X, just what I just read, the X register. And it transfers it, because it's already in the X register, we need to get it into accumulator so we can work with it. So basically, they transferred the X to the accumulator so it can be worked with in the accumulator. And what it does here is it keeps track of high and low bytes in 4 and 5 here. And I found out as I calculated it, so this is basically taking, for example, 0 plus, and you see low to accumulator 192, which gets stored in the 5 here. And you multiply it by 256. This is the high bytes. So it's basically, I found out after some trial and error, that it's actually defining what is on the screen here within these memory locations. And let me just pause and show you. I had actually reload the whole program. It crashed it because I actually ended up poking. It was dumb of me to do that. But anyways, what I want to do is print these values here, and we'll write them down as we see them. So 234 is the first one. There's a 32. 171. And 111. So we can just start with those ones. So let me go back and remember what I said about the sys 21,1,1. This is defining the map parameters. That's what this first parameter is doing, is it's reading in the low byte in the memory. And it's positioning it. So as you go sys 28,1,1, it basically draws the map on the screen. Now we wrote down those values for a reason. So I can show you. Okay, so the 234 we saw earlier, that's printing this little box on the screen here. So if we go through, the 32 is going to be a space. I know that one already. And we put in 171 here. You'll see it basically draws this wall on the screen. And then the 111 should draw like the first place where you start at, right there. So this is drawing in the map into that memory location, 49,152, to however far you're scrolling in memory. So it keeps track of where the map is being drawn. And then here's the second parameter. Actually, this is where it draws the map out to the screen here. This is basically incrementing it by 80 since it needs to go beyond the 80th character line, I believe it is. Not sure what it's doing the 80, but anyways. This next part here, give me 1 second. Oh, here's the other one. I was looking for the other parameter. It's right here. So here's parameter 1, and that's that sys, going back over here again, sys 28,1,1. That's that first parameter right here, this one, for the 1. So if you change this around, you can move it around in memory. This is on the X coordinate, so it's the map coordinate in memory. So if you move it to 10, it should move it over 10. So now I moved the map over 10 there. And then the other one is the Y coordinate, of course. So if you go sys 28, 1, or let's say 10, however far down you want the screen to go, it'll scroll down that many lines. Now it kind of scrolls the map down there. And then that's basically passing a net parameter, and it says if it's equal to 0, then it basically goes to 0362, which is down here. And this resets it back to the actual 1024 location, and that's where it kind of just stores it back on the screen here again. It puts it back to where it started. So anytime you use sys 28,0,0, it just redraws the first map you saw on the screen. I think I kind of explained that good enough. I found out these lines down here in 1150 in the program here, 1150 and so on. Oh, that's the data line, excuse me. So it'd be back in here somewhere. Let me just see where it is. Oh, I gotta turn the map off here real quick. See, right here, line 840, the 850, let's list those real quick. These right here, it's drawn into the 680 here. Oh, actually, it's not 680, I'm sorry, it's 916, excuse me. Probably the next one down. So here's where it draws the map. Right here it is. So it's 910. So that's where I was stored at. So 910, here's where it draws the 916 to 951. It resists, it doesn't do anything, but what it's doing is it's clearing out extra data left on the screen. That's what I found out so far with it. So if you go to rerun the game again, and you've already like basically cleared a monster on the previous screen or cleared a treasure chest, it doesn't reappear in the next one. So I think that's the way that they clear out the garbage, from what I understand. And these are the high and low bytes. You can see again the 0 and the 192. So if we go here and we just type the print 0 plus 192 times 256, you can see it starts in memory location 49,152, which is an empty area of memory where you can draw to. You can also put in a lot of new machine language programs directly into 49,152, according to the MapX 64 book there. So it's interesting, you know, just taking this program apart and learning from it. I went through now. And I'll upload this to my GitHub too. And I went through and I just redefined, basically reverse engineered a lot of this here. I had, like I said, an earlier video where I went through it line by line, but it took way too long, so I decided just to redo the video. I found out these define functions that are stored in here. I didn't show you on that one. I can show you on this. I'm not going to do every single line, but if you see this line 120 here, this is a function where you see fnx. Basically, you just separate it like this, and you can kind of see what the function is doing. And it'll print out a value. So that's actually a screen memory location. Isn't that interesting? I just ran that earlier. So if I go in here and I type it in, I think that might be our character position. Yeah, actually, X is the character position. Hey, I just now learned out what that line did. I didn't know what that line... Oh, yeah, I did. Position the character sprite X, comma Y. So that positions it wherever your character is moving around. That function keeps track of it. And a function is a way of using a mathematical algorithm to kind of speed up that part. Instead of, because calculations can kind of slow down BASIC, functions are supposed to make it a little bit easier on BASIC. So it kind of speeds it up a little bit. And I think it saves on memory a little bit too. And here's a function here that keeps track of the joystick. You probably won't see anything on this because we haven't moved the joystick. I'm just curious if we moved the joystick, if that would have changed this at all. It probably won't because we haven't peeked into it or anything. So never mind that one. Yeah, I created that line by accident. Okay, so these are all the functions right here. You can just print them. Like I said, just separate the fn from the value there, and you can see what the function's doing. That would give me an undefined for some reason. Sometimes BASIC doesn't like to remember them after you try to bring them back in. Yeah, I'd have to rerun the program again or something. It seems to... Oh, because I went over a line again. I'd have to rerun it again. But let me just pause here. So I listed out some more functions on the screen here to kind of show you. So if you type over a line like you saw me erase that earlier, that just basically reset the variable pointer in memory and erased all the variables. So I had to go ahead and rerun them again. So I made a little miscalculation here. So whenever you define the function here, after you go ahead and do the function, you have to cast in a variable value here. You can't just put in a number in there. So that's why it didn't work before. But now you can see it's printing in the 53 through 48, the function I just created here in lines line 115 and dimension and line 112. So I wanted to show you that so that you can see like what the functions are doing, and you can just print through them. Like I said, just separate the values. This one is for the positions for the enemy on the screen. X and Y positions right there. Positions the enemy character on the screen, and then so on. This one is a... I'm sure what this one was doing. I couldn't figure that one out. But that's what the functions do. They basically allow a way of defining variables that you can use to speed up the calculations within the program. Because this one uses some complicated routines like the map and that, and reloading the map on every movement, I think that's probably why they use the functions. But yeah, that's pretty much what I wanted to show you with that. We took apart the code and went through some of the functions, and I'll post this on GitHub so you guys can kind of take a look at it. And if you want to play with it, I didn't want to spend a lot of time going over every single thing, but I found different things in here. Like you can see, some of the stuff is kind of given what starts the game over here. Reset monster positions, and just different things I found out playing with it. And let's take a look here. I took apart the Go subs here, and I just wrote in different stuffs here as I was just kind of reverse engineering this. So I wasn't going to create a whole lot of videos on this, and here's where I really did a lot of the define. I wrote them all out and tried to figure out what each one of them is doing and started printing out the values of each one. And then here's some of the variables that's defined in the program. And here's some things I found out for the boundaries and stuff like that. Actually, this is not monster. This is MapX. I used to think this was the monster, but the MX is actually for the MapX and the MapY. Because remember I showed you if you do that system 828, comma whatever, it'll just move the map around in memory for you. Versus if you just do the regular, it'll figure out where the map is you drew. Otherwise, if you draw outside of those boundaries in memory, it's going to pick up a different area and start drawing down the map here. So I think if I did this one earlier, it started drawing down the screen. Let me see, 828, that's probably too far. So the map goes over, the screen goes over from 0 to 40. So if you go 40, probably even 41 will probably do it. Like that, it draws over the line there. If you change this to like 44 or something, it'll start drawing in and it starts kind of scrolling the map down. But if you do something like this, 42, 1, maybe let's try 52. I'm just trying to get it, it's doing some weird scrolling there. Say 40, 4, there it is. It starts picking up the bottom part, next part of memory that's not defined yet, and it kind of starts scrolling through memory. So if we created a program, we could actually scroll through it here. I'm just curious if we did this real quick, what would happen. You can probably see different parts of memory as we're scrolling through it. We'll just set this to 1, and let's see what happens here. Kind of can see a little scrolling going on there. That's kind of cool. Probably do it the reverse by changing the other parameter. Just leaving this to 1 and setting this to X, and it does the vertical. And you can kind of see now it's scrolling through memory. Kind of cool, I think. It's like a memory scroller. But yeah, that's all I was going to do with this video. I said didn't really have a whole lot more planned for this. Just showed you all the stuff I did, you know, and as we ran the game and stuff like that. I haven't really changed anything with the startup screens. I know I've been pausing a lot, so you haven't been able to see all this. So this is all the same. I did redefine one of the other characters here. So I'm going to stop here for a second and show you something else here. I think I just crashed it. Yeah, also, there's another thing. If you press the keys while it's running, the interrupt crashes the keyboard, so that's something else I'll need to fix. This time I won't touch the keyboard. Last time I touched the keyboard and it crashed it, so I'm just going to let it go. I was going to show you the redefined characters, but you never want to touch the keyboard while it's trying to move memory around there. So I'm just going to pause this for a second, and then I'll show you like the character. So if you press like the number key there, you got the little enemy there. If you press like the 2 or 3 or 4, I'm sorry, you got the other one, that's the spirit. And 5, you got the little bat. 6, you got, I don't know what that one was. 7, 8, 9 is the key. 0, 0, of course. And trying to see if there was any other ones they defined here. I think they did the star. You just press the keys and you can see what's redefined or not. They only did a few characters in it, really. Now, I created another separate program here. I think I might have it up here. I need to pause it for a second. Let me see if it's not crashed. Right here. And I'll run this to show you. This is the version I want to do for the multiplayer. Not touching the keyboard. I guess I could have paused. I forgot to pause there. But it'll load it here in just a second. There it goes. So it works the same. You can move around and stuff like that. Do that map, sys 828, 1, 1, or whatever, x, x. And then here, I'll show you. I'm going to turn off this color, turn on this color, so we can kind of clear the screen here a little bit. And I'll show you the colors, like the characters I defined. So there's like a brick wall there, and there's different ones I have in here. And these are taken from another game that I was working on. I need to run the spaced out game. So if we go here and we do this one, this is another multicolor. You see it's got like multiple colors in it. That's why they call it multicolor. It's got like a red and a thing there. You get some kind of, you know, nice attractive looking colors. Now, of course, the lighters look kind of funny, you know, because they're a multicolor. And that's inverse. But yeah, I just wanted to show that to you. I'm going to go ahead and pause here for now. And so, I hope you guys enjoyed this short tutorial. Like I said, try to keep them short here. So, we'll be doing another reverse engineering. We're pretty much done with this one. I'm not going to really try to do much more. If I decide to make it into a better game, maybe I'll upload that video for, you know, reverse engineering number 3 or whatever. But for now, I'm just going to end this series for this one, and then we're going to start another reverse engineering for a different another game in BASIC that I've been wanting to show you. So thanks guys for watching. As always, I really appreciate all your subscriptions, and I appreciate your likes, favorites, and all that, and your comments. I'm really trying to get this Commodore 64, YouTube channel off the ground here. It's really hard promoting a very old computer, and trying to get people's attention with it, because a lot of people have moved on to more common and more modern day computers these days, and that kind of gaming is in, and this old kind of gaming, it's still, the retro still in, and you see a lot of videos, but you just don't see a lot of views on them, because a lot of people weren't up, a lot of kids, for example, around these days weren't growing up around in that time age, so they don't really know. You watch a really interesting video on YouTube. There's one, I can't think of the name of it right now, but basically these kids go and they start playing with the Commodore 64 and they don't really understand it. They're playing with an Apple computer and they don't even know how to turn it on and stuff like that. So it's kind of an interesting video if you want to check that out sometime. So yeah, I really appreciate everything. You guys are awesome, and keep on rocking. Thanks for watching.